I would like to start by pointing out the absolute profusion in big data related technology and innovation. As you are all aware, there is seemingly every day advances in the technical stack around big data. And what I would offer to you as enterprise architects and chief technologists is that the purview goes beyond just the category of big data, that the broader category of analytics in your purview encompasses traditional technology stack in business intelligence and analytics. There's also cloud technologies that are springing up in this area. With the proliferation of products like Tableau, you can also see the democratization of self-service business intelligence. And so all of these innovations and technologies certainly hold tremendous promise. I was very much inspired by the keynote presentation that just preceded our panel discussion. And yet many of you also see new arising challenges with all of this plethora of technology. In particular, there are multiple redundant efforts regarding ingestion of data, preparation of data. There's also additional responsibility and accountability regarding the security of data, specifically sensitive information like PII or healthcare data. And so there is increased risk with all of this potential. And in particular, there are risk areas concerning the information quality. There's risk in terms of the inconsistency of the data, having all sorts of different efforts and all sorts of different persistence technologies where you have to store and prepare the data. And then certainly the security is something that is now a topic that we have discussed earlier. Now, one approach that people have taken around this is to invest in another layer. And I would posit to you that if you could take a platform dedicated specifically to data, not beholden to one application or one persistence technology, but looking at data as a whole, we can look at a platform on two levels. One is there has to be a platform that has commonality around security, performance, governance, and collaboration. Our panelists are prepared to give a lot of insight into that. And the other way to look at this platform is there needs to be a holistic and comprehensive management of the ingestion, the preparation, the cleansing, curation or mastering, if you will, and provisioning of data. And as we rethink data architecture for the enterprise, I would call upon this forum and our industry to really rethink how it is that we invest in this new layer of technology.
I'm a little bit out of my place here normally because we're a large construction company. But I'd like to raise it up about 30,000 feet. I'm really glad GE spoke just before we did because he talked about everything I'd like to, but I don't have enough time to. So it was great that he set the platform for it. I want to raise it about 30,000 feet about challenges and opportunities in the real world. Skanska is we're about a $20 billion global construction company. We finance, design, and build some of the largest physical infrastructure, the things that we want to be the internet of, we put in devices, power plants, transportation, rail, on the infrastructure side, and then buildings, data centers, hospitals, stadiums, airports. And one of the things about being one of the oldest industries in the world is that we're successful by segregating, quantifying, and managing risk. That's how you stay in business. We're extremely high volume, very low margin business that manages risk. And how do we do that? Well, we have to quantify it. And ever since, chisel in stone or, ink on parchment, our way of managing and collecting data and the legal and business constructs around that have just completely kept all of the data generation and management within the silos of those stakeholders and those business constructs. So if you want to build a new building, you have to buy land. Well, who do you go to? You have the landowner, you have the local communities. That's one series of stakeholders. And then you have the design and the engineering and the construction. That's another series of stakeholders. And you get the users and the operators, and that's another series of stakeholders. And so there are all these layers of data that get generated, and there is has been, up until now, there has been no reason. In fact, there's been a resistance to want to share that data. Why would you? Because you're dealing with that risk and that data within those constructs. So that's the challenge, because we have all of these things that would keep you from doing that. Now, the opportunity. Things are changing, just as Uber and Zipcar and other things are changing the way we think about transportation. The way we think about ownership and building is changing. There's concepts of things like comfort as a service instead of getting your power bill and your water bill. Buildings are now being forced, we're thinking about more sustainability, and I know I'm going to go over 2 minutes, but please bear with me. More about sustainability. People want buildings that are safe and healthy and secure. And here in the state of California, Title 24, by 2030, every new commercial building will have to be net zero energy. And by 2020, every new residential building will have to be net zero energy. So how do we do that? How do we build that in an environment? So there are new technologies that are coming out, and this is the big data play I'm going to lay out here for a second. Phase change materials, smart buildings that react to the environment, the way that buildings react to the grid, virtual design and construction, moving into the building information model where you have not just static, but as the building's being built and the things that are being put in there, how are they tagged and pulled into a living environment? We're under an initiative right now that are looking at wearables for the construction worker, everything from video data to noise-canceling headphones and real-time communication to repetitive strain to relationships to equipment. So all of a sudden, there's a whole new layer there that has spectrum management, data collection. Your minds could go off. Smart lighting in the way that we think about health in a building, right? And then the whole back office part of it. So the stack there that you're looking in front, I actually stole that from Statoil in Norway, because they look at the different layers of how we think about data across this large physical enterprise that is so important to all of us, the sensor networks, the infrastructure, the analytics that go forward. So the challenge today is this. We've got this historical context for business that is very stratified and very isolated, and yet there's this big hunger, and with the digitally aware generation now coming into business management, they're saying, why can't we? And we have all these new technologies that are coming out that require interrelatedness in order for that to happen. But there's no voice of a single owner because they're across so many. So that's the challenge. You know, what's going to be the business model for this? And for us, we see it as not just a differentiator, but a transformative leapfrogging that is required to move us forward.
We talk about the big data a lot. I'm just going to focus on the healthcare part of it. And the reason is, it's all about the outcomes. I've seen a few people from the healthcare industry in here. How does it help drive a different outcome in the industry? It's clinical quality, operational efficiency, and the financial performance, because you guys know healthcare cost is going up. No surprise, it is under pressure. The industry is under pressure. And actually, information is hidden. In a hidden way in different places. We currently have the data. It was interesting to hear the security aspects of it and how people were looking at the data. We should actually look at it. Hey, if it is trapped there, why are you not using it to help the industry, reduce the cost, deliver better quality healthcare, and help me actually find out what it is that we can do? Here's an example. I'm not a doctor. I'm a software guy. But when I saw this one and they asked me, hey, Aaron, do you see where the lymphoma is? I said, what is a lymphoma was my first question. And then I learned what lymphoma meant. Well, actually, the machines who are actually able to learn and look at the anomalies can determine where that is. And we have this data everywhere. Every time you go and get a pathology test done somewhere, they do it manually. It's the most wasteful thing we have in the industry. In some parts of the world, we actually thought that we automated some of these things, but it's just hidden in there. We are working with our pharma companies, the customers. At the cell level, we're trying to figure out what we can do to attack the cancer cell. And when we saved the life of a 6-year-old girl, we were all celebrating because it was able to actually detect it, and it was the data. We didn't have the ability to capture the data, do something about it. It's all in there now. Can we turn this into an actionable, either a drug or treatment or whatever that we can do? I remember when my first boy was born, the ultrasound images that we were getting were like, at best, blurry. And we were looking, oh, look at this, and he's a boy. I said, well, what? How can you tell it's a boy? Look at now, I mean, it almost looks like, you know, the father of the kid. That's what they were saying when we were looking.
How can you tell that this is a boy?
Well, you know, we had the other part of the body too. We had the other part of the body too, so we actually focused on the other part. Great question.
Prettier at birth
but
than that, you know.
but you can actually see where this is going, and then you know, there's other parts of it that we look at it where the blood is flowing and how it's flowing. Early stages, we can actually determine what needs to be done, because there are a lot of kids premature kids being born, not getting the right treatment, and it is not only stressful to the families, but stressful to the whole industry. In the end, it's all about the outcomes, and that we're going to drive those solutions. Everything else is an enabler. The big buzzword, the big data, the analytics, and so forth, if we're not actually doing something, improving the health, reducing the cost, we're not really doing anything. That's how we look at it.
We talk here and outside of this room a lot about data, and always the underlying promise, we can do loads of it. And then we see those things, we can identify boys, and Matthew gave an awesome explanation of how data can be actually used. This was very stunning, but it comes always down to, how would you do this? How do you use data? And it breaks down as, how do you build a data-driven culture, right? So, and very often I see this in companies who then come on campus, visit us at LinkedIn, and kind of like have the underlying question, what do we need to do? So first, it's a mindset question. And Matthew showed this very nicely in his curve, kind of like what's analytics. First you chart, and then the doctor tells you have an issue, but what's a prescriptive analytics? So the mindset means it's a top-down approach. In order to become business-driven, like data-driven, have the right business question. That's what I call here the ask, right? Have the right ask in place. And that is by no means an easy thing, because we have our business, we have our targets, we have our things to do, and now somebody says, well, we could do different, but we don't really know what different means. So the ask, to come up with the ask is difficult, and we kind of like build a lot of tools from automated analytics over different other ways where we're kind of saying we do business analytics or we do data science in order to come up with the ask. Now the measure, very, very, very needed in the whole thing. If you don't have data, then you obviously, even when you have a good ask, you won't succeed. And then the learn, again, is a cultural thing. If you enable your whole company to think data, to think about what can I actually do with the data and take decision based on data, it's a cultural thing, because so far we didn't have the data, and therefore we didn't do it. Kind of that's an important step in order to do, like in order to break down a company into a cultural, data-driven company. It becomes obviously way easier for a company like LinkedIn, right? We are by nature a data company. We have built up a culture. We are very, very data-driven. We have very close interaction between data scientists, engineers, business people. Comes over to the second step, like it's a skill set question. What kind of skills do you need as a company today to build this data-driven culture? And the skill set is pretty much made up of, like people talk about the data scientists, and we all know they can walk on the water and they really glow in the dark, and they're very, very hard to find. Now, that's the wrong approach. We don't need to look for somebody who does it all. We need for skill sets, which we can then combine in a data science team, which is engineering, statistics, business. And if you drill down, you will see I kind of like have been a little bit more concrete. That's the way how we as well organize. When we build tools, we have normally all areas of the business on the table, like so all areas of data on the table. We have the business owner who kind of says, I had the question. We have the data people who said, I know the measure and I know where the data comes from. And we have the people who put it then in an interface or who put it in process flow.
I'm going to discuss the Chief Data Officer, which is, of course, the senior strategy position in this new era of enterprises driven by big data analytics. The Chief Data Officer is one half CIO in the sense that they have responsibility for knowledge worker productivity, business intelligence reporting, decision support, and one half Chief Data Science Officer, having responsibility for managing the data science brain trust, your data scientist and the tools and strategies that are driven by data science. And really, data science is the chief differentiator increasingly in this modern economy. And data science is, in many ways, is the core skill set of the new generation of app developers. Because more and more applications, as we've seen at this conference, are driven by data science, by machine learning models, predictive analytics, social graph analysis. All of that is very much at the heart of the modern application in the cloud, where the execution logic of your application is driven in whole or in great part by rules that are derived from the data. And the GE speaker who came before us did a wonderful job of explaining exactly that logic. The logic of predictive models. The offer you make to a customer in a given occasion, like right now, to a given customer, might be very different from what you would have made to them yesterday, because fresh data has come in on their propensities and their interests and so forth. And so data science, machine learning models and so forth are your chief tool now for building that application logic and deriving it implicitly from the data in real time to optimize your business. So if you look at that, the notion that the data scientist is the primary resource, and data science tools and models, algorithms, are the principal resource for business success now. It's clear that we're in a new era of computing. It's the cognitive systems era. Cognitive computing, it's a term, of course, that we've used in the context of Watson and so forth. Cognitive computing is all about, it's really artificial intelligence for the 21st century, for the era of big data, multi-structured data, unstructured data, and so forth. So if you look at what we're in now, more and more of the application logic is being derived implicitly from the data. Of course, this is building on the era that we're still very much in as well, the programmable systems era, where the execution logic has to be explicitly programmed by a team of coders, programmers, and so forth. And that's clearly been the era that we've been in ever since World War II. And the great revolutionary frameworks and approaches defined by Alan Turing and John von Neumann, et cetera, have very much built up the programmable systems era, where it was software explicit execution logic. And of course, that followed on a long period of time where computing, as it was known back then, or calculating, tabulating, the tabulating systems era, where the execution logic had to be hardwired and baked into the hardware itself. You still need all that. So if you look at this chart right now, the x-axis is the axis of time, clearly, going back to the start of the 20th century, and IBM's pretty freaking old, so that pretty much extends across our entire life so far as a corporation. It's a cumulative process. We still have hardware and firmware at the heart of everything. We still have software, but now we have big data, and we need our data scientists to help us leverage the insights that are supplied in the data. So fundamentally, the cognitive systems era is all about dynamically evolving the application logic from fresh data, and then driving that into all of your business processes.